Welcome everyone. Thank you for joining us today. I thank you for your time. So the webinar today is about managing the impact of ever-changing requirements. So as I mentioned before, my name is Paul Hewitt. I'm the VP of Sales for the UK and Ireland, and I'm going to be supported today by Miguel Tomico, one of our senior requirements consultants. So I will start the presentation. A bit of housekeeping just to start off. During the webinar we will keep the microphones on mute. If you want to raise any questions at any time, please use the online chat box, and we will aim to answer your questions during the Q&A session and discussion at the end of the session. So please, make it interactive. It makes it certainly more fun for us if we can have some questions and challenging things to answer at the end. But certainly feel free to post your questions during the session. So with that, I will start, and I hope you find the session of value. So going to the next slide. So just to give you an idea of the agenda for today, there's a very brief view of who we are, who Visure are, and our focus on requirements management. We'll then go into looking at some of the business challenges of requirements change and how you manage those challenges. And with that, we go through a little bit of information on understanding the power of information traceability and the potential benefit that it can give your projects, and the effective management of change on reused requirements and some of the challenges that may bring forward. At that point, we'll actually do a very quick demonstration of how you can actually address some of those business challenges around managing change and the impact of change, and understanding what in your whole project is touched by change, should it occur at any time. And then at the end, after the demonstration, I'll go through some of the business benefits of the effect of effective change management, and at which point I'll open it out for a general discussion and questions. So with that, I will start. So Visure, very briefly, we're very much a company specializing absolute focus on requirements engineering for system engineering and complex IT systems. Visure was founded in 2007, although the technology has been around since the late 1990s, to focus on the delivery of innovative requirements solutions. We're a manufacturer of Visure requirements, a leading requirement solution. We have headquarters now in Madrid and in California and San Francisco in the USA, and offices in UK, Sweden and Germany. We are ISO SPICE certified, and that's in reflection of a lot of the work we're doing in Germany within the automotive industry sector. And we also are IREB certified, which is the International Requirement Engineering Board, for certification of requirement engineers, and we actually have a certified training course that we deliver to support that. So enough about Visure. Let's go on to talk about managing changing requirements. So before I start, just to give you a little story, if you like, to set the context and to just understand some of the implications of a single requirement change having a significant impact on a project. So the RM5 was a project, an unfortunate project that in 1996 the RM5 rocket exploded after just 37 seconds. So after 10 years and $7 billion of development, the maiden flight of RM5 exploded. the cost of the equipment, the payload alone, was estimated to be worth something in the region of $500 million. And this was due to a specification design errors in the software of the backup and active inertial reference systems. The development program did not include adequate analysis and testing for the inertial reference system or of the complete flight control system. So what changed? Well, several things changed. First and foremost, the actual inertial reference system in RM5 was identical to the system that was actually used in the previous very successful Ariane 4 launch. But the thing that had changed is the payload in Ariane 5 was significantly larger than that of Ariane 4, and the initial reference system was responsible for transmitting commands to the engine to maintain altitude and direction. The software actually failed when there was an attempt to convert the 16-bit floating point number into a signed 16-bit integer, causing the number to effectively overflow. Interesting view on redundancy they had here as well, because the backup software was literally identical to the primary software, and not surprisingly behaved in precisely the same way as the primary software, causing after 37 seconds the rocket to go off course and explode. So, and more significantly here, the system was actually designed with actually a single point of failure, which most critical or safety or software critical systems now would not entertain. But the change occurred with the payload and the impact and effect that had on the on the launch characteristics of the actual rocket. So one change to one requirement, and that was the net impact of that change. So moving on, so I'm going to start now by saying welcome to my project team. So you are all now members of my project team, and here we're having our project launch meeting. And our project launch meeting, here I've got some information on a chart, typical thing, and we've got the concept. That's very exciting. We're coming down to a product, and in the bottom right corner, of course, we are anticipating success. What's interesting about this chart, which I happen to like, is the fact it's even got traceability. We've got this idea of information flowing to other bits of information, and traceability between those artifacts. So, well, I would probably term this as chaos. It's as good as just to set the scene and so forth. Now let's go on to the next stage of our project planning. Well, very often projects, and I'm sure this doesn't apply to you on the call here, but very often projects start with what I term as autonomous islands of information, which very often are in the form of Word documents, Excel spreadsheets, minutes of meetings, tweets, blogs, whatever form information flow takes. And here is this example where you've got all these bits of information. There's no actual explicit traceability between those bits of information, but they're all information which are relevant to this project. And so I now think about, well, how can we, and this is what I've termed, if you like, the chaos end of the spectrum. So here I've got islands of information. We have discussions about not particularly well shared, and how do we take them to go from chaos into order. So what we try and do with this information is take this and organize it into the documents below the line here. So these documents, you notice now the documents have got lines showing links between the documents. Well, the links here are not at individual statement level within those documents. And by starting to establish these links between the information, establish this thread of traceability, we start to bring some order into this information. But again, this information is no good if everyone within the project team doesn't have equal access to the information they require to actually perform their jobs. So the next challenge is we've got to make this information centrally available to everyone in real time, but I'll cover that a little later on. So moving to the next slide. Oops, it went. Okay. So the challenge here is we need to make one change to a system requirement. So here's a typical sort of V-curve of a system engineering lifecycle, and in the system specification I want to make a change to that one statement. Well, this diagram very clearly shows that that system specification does not stand alone. It's not an island of information. It's actually connected with other bits of information. So if the system requirement changes, what is the impact on the system test to the right? If the system requirement changes, am I still compliant with the original customer requirement? And if the customer requirement for whatever reason needs to change as a result of that system requirement change, does it impact on the customer verification? Am I still testing for the right thing? Going down the tree, if my system requirement changes, what impact does that have on my subsystem requirements? And in turn, if they have to change as a result of this, does that impact on my subsystem test? So the question I'm asking here is, what is touched by one request for change on one requirement of one document? Well, when we start to actually introduce traceability, explicit traceability between these documents, you can very quickly assess what is touched and what is impacted by that change. So let's go through some of the business challenges that we encounter when we don't have effective traceability across documents. So the first business challenge I've got here is, why document the as-built system rather than the as-specified system? I'll let you have a couple of seconds to think about that, because it's quite an important point. The as-specified system is the thing that typically happens at the beginning of a project. They are the requirements given to you by your customer, by your marketing department, wherever the source of requirements. It could even be regulations or standards. So the specified system is what happens at the beginning. But as we all know, life says that changes happen. Through the life of a project, change will happen. So when change happens, we need to make sure that the documentation associated with that project continues as an integral part of that project to reflect the as-built system, the as-developing system, rather than the system that was specified at the beginning. Now, if we don't do that, the business impact is, one, we miss the opportunity for reuse. So we don't want to reuse the as-specified information when effectively that's gone out of date. We need the ability to reuse the as-built information so that we know we're using information which has been validated by a previous delivered system. And of course, the user guides and training need to be based on the as-built system, not the as-specified system, for precisely the same reason. And of course, what it also means potentially is that we're working on what could then be termed out-of-date information. So there's the business impact. The next business challenge is, what is the cost to the project when the full impact of requirements change is not quickly identified? Well, the graphic kind of says it all. You know, you've got two teams of people. They're going to come to converge at some point in the middle to create this wonderful integrated system. And whoops, we've missed. And the business impact is we're working on an out-of-date information, resulting in expensive rework and the later in the life cycle that rework occurs, typically the more expensive that rework costs, particularly if it's actually a delivered system. That you've often heard of many automotive challenges where systems have been delivered to market. I think Toyota seems to stand out at the moment, where systems are delivered to market and then they have to have a recall. The cost of dealing with that, of course, goes exponential, resulting finally there in project overruns and ultimately increased costs. So the next business challenge is, how does one requirement change in one specification impact one or many requirements in other associated specifications? And this is this thing of, you know, how quickly can we identify the impact of that change? How quickly can we assess that change? Very often when we're supplying to customers, we always want to do the right thing. If they ask us to jump, we tend to try and jump where we can. But you've got to sometimes think about what is the impact of the project, both in terms of time, resources, and of course the associated costs. So the impact is impact of change resulting in retrospective rework, project delays, and additional cost. The next business challenge is how do we ensure that subcontracted system requirements or outsourced software requirements are fully satisfied. And this is where you need to create this one-to-one traceability from your specification to how you're going to measure that they're delivering on that item of the specification. And it has to be a one-to-one traceability. So the business impact is we end up with system integration failure, which involves rework, associated delays, and of course then again cost overruns. And finally, the final business challenge I'm talking about today is how do we maintain explicit compliance to standards, legislation, and regulatory constraints. And this is this thing that I've seen often happen in projects where your customer will make a glib or casual reference to a standard or a regulation, which itself could be a 100 or 200 page document. When you look at that document, maybe, I don't know, 10% of that standard or regulation is relevant to this instance of this project. Very quickly we need to assess what that 10% is, and they need to translate into requirements that need to be verified. But just as importantly, we need to think about what are the 90% of those requirements which are not relevant to this instance of this project. And then, having defined that division between the parts which are relevant and the parts which are not relevant, we need to agree that back with the customer at the earliest possible stage, so that one, we're not over-engineering, and two, we're not not missing anything that the regulation they've specified specifies. So business impact, retrospective rework, and if you're working for a government organization, this can also result in penalties and fines for non-compliance, particularly if it's, for instance, it's a safety critical system. So moving on, so requirements management must provide traceability throughout the life cycle, and this traceability and these documents must form a living part of the project through the life cycle. And in forming a living part of that project, then you start to build, as an integral part of the project, a true view of the as-built and, more importantly, as-delivered system rather than the as-specified system. So traceability is key to maintaining this compliance. Initial requirements will be decomposed, which creates traceability relationships. Traceability must be enforced in order to ensure consistency and completeness of your project information throughout the life cycle. Traceability from your customer requirements through to your system development to test and the delivery enables organizations to know which requirements are implemented and tested versus which are not. And you can run metrics reporting on this at any instance in time if you maintain this traceability. I regard this traceability as like cobwebs, invisible lines which are linking sentences together across multiple documents. And the value of maintaining these invisible lines we'll discover in a minute, but it's really critical to ensure that we don't miss anything during the project lifecycle. We can manage and defend against scope creep, that gold plating or that platinum plating that often happens. And that's a situation where you've defined some system requirements which you cannot trace back to user requirements. Now, it could be relevant that you do that, but at least you've got to ask the question, why do those system requirements not trace back to user requirements? Are we over-engineering? Are we adding more capability to the project than the customers actually asked for? And also to ensure explicit traceability to regulatory requirements and associated compliance. Regulatory requirements, associated compliance. So the importance and process of collaboration. So to ensure that we get consistency across not just one project, but every project we run, process is imperative. Having a common process, having common relationships that you agree across these projects. Establishing this traceability, again, not at document level, but at individual statement level within those documents to provide consistency. And then centralizing this information, having what I term here as one view of the truth that everyone in the project who needs to access it has access to. Not multiple copies of Word documents and Excel documents, which can say slightly different things. Having one view of the truth that everyone is working to, and if one requirement needs to change, that change should be available to everyone working in the project in real time, so that they know that change has been made, and they can already instantly look at and consider the impact that requirement change may have on the part of the system they are responsible for. But that has to be effective, that has to happen in real time. We need to avoid what I call the canteen discussion. That discussion in the canteen that you have with one of your colleagues, the engineer talking to one of the test engineers, and the engineer says, a very simple example, but, oh, have you heard that such and such, we changed the color from green to red? And the test engineer says, well, no one's told me, as far as I'm concerned. I'm still testing against something that's green. If it comes through to me and it's red, I'm going to fail it, because no one said. Simple, trivial example, but it just emphasizes the point that we've got to have one central version of the truth and move away from distributed islands of information. If we achieve the first two, the process and the collaboration, what we get as a byproduct of this is increased product quality, increased assurance that we've covered all the bases and that everything is complete, that everything traces to test and verification, that every user requirement has in some way or another been satisfied by a system requirement. So the life cycle is we capture the information, having captured the information. That information, by the way, can come from multiple sources. It can be your user requirements, it can be your marketing department, it can be standards and regulatory compliance, which you need to introduce as requirements into the start of the project. Having captured the requirements and organized them, we can start to analyze those requirements, analyze them and say, well, how are we going to satisfy those requirements in terms of our system? Have we got off-the-shelf equipment that will satisfy them? And if so, how much? And how much new system development we then need to specify and actually implement. Having done that, we now move around the cycle to thinking how we're going to validate and verify that we're going to satisfy those things, to complete that loop, and to have that information central so that everyone in the project who needs access to it has access to it. This also works for what we term product line and variant management. So here I have an example where we have a common chassis, typical car example, common chassis, and that's a project in its own right. That chassis, that common chassis now is used by three vehicle variants. There's a saloon car variant, there's a sports car variant, and then there's a utility car variant, each their own projects. Now each of those projects by themselves cannot actually make any changes to that chassis, because the chassis project and the requirements associated with that chassis are owned by project number one. They're reusing that chassis, absolutely. Now if they need to make a change to that chassis, they can't. They can propose changes to the chassis, but it has to go back to project number one for project number one to actually do an impact analysis that says, if I change that chassis, what impact is it going to have on, if I change it for the saloon car variant, what impact will it have on my project, my sports car variant and my utility car variant? Is it a change that could easily accommodate and add benefit to those other two variants? It's a question. But by establishing that traceability, it's a question you can legitimately ask and actually manage. It could be that the saloon car variant does need a specific change to the chassis, which does make it different to the other two, which means we'll have to create a new instance of chassis for that vehicle. Not what we want to achieve, by the way, because obviously most companies want to establish as much common equipment as possible to reduce cost and get the economy of scale of having a common chassis which can be used on multiple variants. Now, going on further, these reuse components, when you try and make a change or you propose a change, this immediately should come up with what we call the suspect link. It flags to the other end of the party that a change is occurring, and we need to assess what the impact of that change is, or indeed whether we can actually accept the change. But also, when we try and introduce change, we need to almost in real time understand what is touched by that change, what is impacted by that change. And if we understand those things in real time, we can very quickly respond to the customer and say, yes, we can implement that change, but the impact on the current program is, in terms of time, it's going to take longer, it's going to take more resource, it's going to take more activity, and therefore it's going to have an impact on cost. Is that acceptable? And the quicker we can make that assessment, the less delay we're going to introduce into the project by introducing that change. It also hopefully stops us just saying yes when it should be yes but the impact is. Now we can actually reuse information by sharing it, by copying and linking the information, or by just copying the information. And if you copy the information, of course, you're effectively creating a new instance of that chassis for each new project. And I go back here now to the process and the importance of the process and the importance of defining at the beginning of the project how the information in the project is linked together. So here I've got an example of user requirements. The user requirements are derived from customer requirements, marketing requirements, standards, which in this case are actually a standard, are actually a project in their own right and reused, and then business rules. Notice that the user requirements are satisfied by system requirements. Can everybody still hear me? I'm just noticing I've got a slight network problem there. I think
yep.
You can still hear me, can you?
I can.
Oh, perfect. Okay, good. Thank you. So the user requirements are satisfied by system requirements. The system requirements are validated by system tests. But notice now the system requirements again satisfied by subsystem requirements, which in turn are validated by subsystem tests. The user requirements and the system requirements they can also promote risks. So project risk can be motivated in this case by those user requirements and system requirements. So moving on, I will now hand over to Miguel, who will actually show in the form of a demonstration how we can actually maintain and actually establish this traceability and manage this impact of change throughout the life of the project. So Miguel, if I can hand across to you. Thank you.
Thanks a lot, Paul. That was a brilliant demonstration. Well, let me just demonstrate in 10 minutes, just as you say, demonstrate how a tool can help to manage and identify and manage requirements changes and assess its impact through traceability analysis. We will use a similar diagram to the one that Paul introduced before. Let's assume that we have some high-level user requirements coming from different stakeholders or sources of information. It can be customers, marketing, standards, or business rules. This is just an example, obviously. And these user requirements are satisfied or implemented in terms of system requirements. And also these system requirements are satisfied by several subsystem specifications. In the right side of the V model, we have also the tests. So let's assume that in this example, the product manager of a surgical imaging system is responsible for the specification of these system requirements. Okay? While, in the other hand, a system engineer, as you can see, I will use two roles here, logging in the same project. This system engineer, starting from the high-level system requirements, will write the low-level subsystem specification for each subsystem to satisfy those system requirements and also establish the relationships between them to make sure that we don't miss anything along the way. So we would expect every system requirement to be satisfied by at least a subsystem requirement, and likewise we would expect every system requirement to be validated by a system test, and also that every subsystem requirement is validated by a subsystem test. Okay, so let's assume that once the project is in a stable phase and the system and subsystem specification has been written and also traced, as you can see here in the matrix, we have the system requirements in rows while the subsystem requirements in columns, and I have established the links between them. So, well, let's assume that a change in the standard arises requiring changes in the specification. Or maybe it is the customer who made a request for a change. So, in this case, let's assume, and let me go back to the product manager role, let's assume that the company has decided to start selling this surgical imaging product, not just in the United States, but also, for instance, in Asia. Therefore, we may need to change the system specification. In particular, some changes are needed for the power supply cables. So the product manager will modify this requirement accordingly. So let's check it out and modify the description. Let's assume instead of data system, it will be all non-US subsystems. Okay. Let's also change the priority from medium to high, because I want this to be reviewed as soon as possible, and commit the change, giving it a reason. Could be that we need to comply with Asian power blocks. So that's it. Now we will switch, once that I have modified the system specification, I will switch to the system engineer role, and as a system engineer I will be interested in checking the changes made to the system requirements, because I may have to take them into consideration, because I may have to modify the related subsystem requirements. So let me do this analysis again. And as the power supply system requirement has been modified, the arrow has turned red. This is what Paul mentioned with the suspect link. So this is indicating that I need to review it, because the the source has changed. So let's navigate to the source requirement, and I may have to consider the impact of this proposed change. Well, let me go to the properties of that requirement, and I can see that it was the product manager, the one requesting the change. I can see that he requested it recently. And well, and I can also see that he provided a description for or a reason for the change. We need to comply with Asian power plugs. Okay, that's just great. But I want to identify what was actually changed. So what any requirements tool should provide is a mechanism to compare two versions of a requirement, so that I can quickly see in red that the priority has changed, and also the description. And I can even track the changes in the description in a very nice way. So I quickly identify what was changed. Okay, so now that I know the change, I may have to review the related subsystem requirements. So well, let me go back to the matrix. And so I can see that we have two subsystem requirements related with this one. So I can navigate now to the target, just to make sure that we don't miss the change. So yeah, let's assume that, well, once I have reviewed both requirements, I can state that no changes are needed. Therefore, I can safely clear the suspect. So let me go back to the matrix, and I can clear the suspect. Well, in this case, I will clear all row suspects. So it's just great. But what if there are other related artifacts that could have been affected? If we take a look to the diagram again, remember that there are also some system tests and some subsystem tests that I may have to take a look at them. So let's analyze the traceability in a different way, displaying the relationships in a hierarchical way. So as you can see, we have the power supply system requirement along with both subsystem requirements, which in this case are mechanical requirements. Okay. So, well, using these views, we can analyze other kind of relationships and go as deep as we want. So, if we add validated by here, I can also see the related subsystem tests, okay, which is just great. I can see the full traceability in my fingertips. I could just check out the related subsystem test and modify the test result from OK to pending, because I could consider that this test case or this test procedure needs to be executed again in order to be sure that we comply with the new system requirement. Okay, so as you can see, we have made sure that we have taken into account all the low-level artifacts related to the recently modified system requirements. But we should ask ourselves, are we still compliant with the original higher level customer requirement? So let me go to the last time. Remember that we still have to comply with the user requirements. So let me go back again to the traceability view. And in order to do that kind of analysis, because I was analyzing the low-level related artifacts, I can just modify the direction of the relationships just to reflect that I want to analyze the incoming link. So I can quickly see that, well, it is this the customer requirement or the user requirement related with the system requirement. So I have full control over all related artifacts. Okay, so let me go back to the presentation just to summarize. What we have seen here is just some of the features that any tool must have to help identifying requirements changes in a comprehensive way, so that we can provide answers to all these questions that you see on the screen. This will help us to be more productive, don't miss anything in the process. So we can use the tool to instantly assess the full impact of any required change based on what is touched by the change within other related and dependent documents. Through this assessment, we can quickly assess how the project will be affected in terms of costs, time scales, and resources before we actually proceed and implement the requirement changes. Okay, so that's basically it. I will now hand you back to Paul. Paul, it's all yours. Thanks.
Lovely, thank you, Miguel. Right, so going back to this original diagram, we've now asked the question. We were making one change to one system specification requirement, and we were then looking around to see what is touched by that change. Both upwards, are we still compliant with the customer requirement? Downwards, what has been the impact on the subsystem specification requirements? And of course, across to the right, to see what impact does it have on our various tests and verifications. So we can see what is touched by one change. And that can be done in real time and visible to everyone working in the project. Now, by way of conclusion, we need to make an investment in this management of change. So first of all, I'm going to put my hands up and say, look, there are no silver bullets or shortcuts here. Establishing and maintaining information traceability, it takes effort to do that. The payback of the effort, though, is you can develop metrics, real-time metrics about where you are with the project. Has every user requirement been satisfied by a system requirement? Has every system requirement been satisfied by a subsystem requirement? In each case, is every user requirement verified by something to enable you to prove compliance with what your customer originally asked you to do? Now, of course, we can do this manually, and my nice little picture, knife and forking it, as I would say. You can do it manually. You can distribute it in Microsoft Excel and Word, these islands of information. But where you don't have that traceability, if someone asks you that question, I want to make this change to this one requirement, what is going to be touched by that change? Having to go round and ask and find out which documents are going to be impacted, which parts of the system are going to be impacted, which other parts of the project are going to be impacted. If you try and do that manually, it's possible, but the opportunity for errors and missing information, as you can probably guess, is high. But, there are no silver bullets, but the value of maintaining that traceability for metrics reporting and for understanding the impact of change in real time is the benefit is huge. So now let's go back to the business benefits. So let's look at the business benefits. Let's turn this around now. Let's look at the business benefits of managing change effectively. So number one, control of project information. Absolute clarity of understanding between all contractual parties and stakeholders. All the stakeholders have a common view of the system, one view of the truth. If one change is made to one requirement, that information should be instantly available to everyone in the project who needs to know at the time it was made, so that they can very quickly assess, how does it affect me? How does it affect my part of the project or the system? The next point is ability to demonstrate absolute compliance with your customer requirements. This in turn makes it easier to secure payments against contractual milestones. It also gives you a real-time view of how far you are through, how many customer requirements trace to some part of a solution, and more importantly, how many don't at this point. And if we say that once we get to 60% traceability, you could then tie a contractual milestone payment to that event. Accurate allocation of requirements to subcontractors and third parties and ensures compliance with the specified requirements. So you end up with this concept of one-to-one traceability. This is what you ask your subcontractor or outsourced party to do and deliver, and this is how you're going to measure that they're actually going to deliver against that. And that's really important to make sure that boundary condition is satisfied and that you don't end up with a situation where when you integrate their contribution back to your main system, it doesn't work. Analysis of the impact of change at any time in the project in real time increases the commercial opportunities and decreases the risk associated with change. Increases the commercial opportunities, particularly around reuse. You're reusing information you validated actually works in the live delivered system. And then finally, I can bring it up, avoids the need for unnecessary and retrospective rework, project recalls, or RM5. So, trying to avoid that cost that can happen at the end of the project, at the very time in a project lifecycle you least want it to happen. So with that, we've now can now open up the discussion to questions. Certainly thank you for your attendance and listening. I very much appreciate that and your time. If there are any questions, if you can type your questions in, if you've got anything you would like to raise with Miguel or myself, and I'll leave it there for a minute or so just to see if anyone wants to raise a question to us that we can answer. I know it takes a little bit of time sometimes for people to type out their question and to see what if they've got anything. Well, it's looking very quiet here, so I think at that, if there are no questions, we'll carry on just talking. If there are no questions, I would like to thank Miguel for supporting me on doing the demonstration, and most importantly to thank you all for your time. I know your time is precious and that you've been able to share a little bit of your time with us. I hope you found the presentation of interest and value, and we will obviously follow up and make contact with you. This presentation has also been recorded, so we can, you will be able to share the recording with your colleagues after the event. So as it looks like I can't see any questions coming in, so I think at this point I will close the session and thank you again for your time. Okay, bye-bye for now. Thank you.